Hi. So we have seen how we have integrated DriveWealth in Salesforce Financial Services Cloud. And now let's take a quick look at the code that we've used to do this integration. To begin with, we have created a DriveWealth API class, and the whole purpose of this class is to accept the API calls from accept the requests, and then it will build the API calls and send the request as needed. So that's all this class does. We built this as per the specifications from DriveWealth APIs for each one, which is to log in, which is create session, get session is to validate the session, search instrument, and so on. And based on that, we send the headers as needed, and we get the code back from there. For each of the requests, we are using a JSON class. These classes are generated from a parser based on the expected results from DriveWealth API. So each class has these variables that we can use with the parse method with the system.json.deserialized, and it will return the instance of that class, and we can easily access the result based on that. To use this API, we built another class, DriveWealth. This class is responsible for requesting the parameters, doing the processing such as complex login parameters, login calls. It will check if there is a valid session already there. If it's there, then it will use that. If not there, then it will rerun the session. And of course, after it's done, it's responsible for cleaning up and again all of the calls that are made to the system for searching the instrument. It's responsible for receiving the parameters, building the correct API, correct request, and the session keys, and sending it to the API class that we built. This adds sort of a wrapper around the API so that we can change the API and then update this class without having to worry about it. Or in most cases, as long as we do not change the response back, we don't have to do anything here. Or if we want to change how the login works, or when we want to do the search instrument, or if we want to change if we want to change the API call underneath, we can simply add another method in the API class, and then we can call it here and use that. So this wrapper approach really helps us to figure out what to do and and have it loosely coupled with the API calls itself. For and then from there we have separate classes. For example, we have a controller for create account where we are using the ETLC Apex Bridge library to get the request for which function to execute. Then we generate the request, and then we use the DriveWealth class to pass the information on, getting the result back, and then sending it back to Lightning components. We make sure that we use the CRUD and FLS check here, and for that matter, we've built this data query class where we do all of our SOQL queries. So we are making sure that we do CRUD and FLS check there, and if we have to change the query, we just change it in one place and use it throughout our logic for the entire project. And then we have in each individual components. For example, the create account that has the flexi page available for all page types, so we can use it anywhere, and the has record ID, so we can use the record ID. And we are also using the external libraries, for example ETLC Apex Bridge, to make Apex calls easier. And we've also built this utility class which we can use to call out functions such as creating dynamic components, or calling the log method so that we can have single logic for console.log based on these flags. If we turn it on, we can see the console.log. If we turn it off, then it's not there. And this can be controlled by these attributes when this component is dropped in app builder. so we don't have to worry about having the debug statements there all the time. And rest is simple Lightning components. We have the logic when this page is loaded, get the information on the load, and then prepare the form that we see if the account is not created. But if the account is already created, then we just display the information that we already have for those accounts. So that's all standard Lightning components. And then for here we have the helper functions where we are using the libraries. For example, when creating an account, we have the is valid where we're checking if this is valid. If not, then we generate dynamic UI messages for each error, and then we use the create components function from the utils Lightning component and call the method there, pass on all of these array values and generate the dynamic UI message. And we will add these in this UI message, which is in here for our component. So taking a quick look at utils method, all it does is it defines the aura method so that we can call those aura methods and the components. And taking a quick look at the log, for in the helper we are saying only do the console.log if the debug client flag is enabled. And that's where this class is very useful. So we don't have to change console.log anywhere, add if statement anywhere else. We just do it here and just turn it on and off. Very, very handy. And of course, this is where we do the create components or a single component and then destroy the components, whereas it'll remove those error messages from UI. So all of that is done here. We can add more functions here eventually to have a sort of a library rather than having to repeat those functions in there. So that's where the aura method tag is very, very handy. So that's pretty much it. Very simple. We simply use Apex callouts to talk to DriveWealth API. Thank you very much.